The chi-square test is a non-parametric statistical test. It is used to determine whether there is a significant difference between observed and expected frequencies in a dataset. It is used to evaluate the association between two categorical variables. A cross-tabulation table is created to display the percentages of outcome in each of the categories of independent variable. Row of the cross-tabulation table will be representing the independent variable or risk factor, while the column of the table will be representing the dependent variable or outcome variable. It is used to evaluate the difference in percentage of categorical outcome variable in different categories of independent variable. Examples of categorical outcome variable or dependent variable include presence of cardiovascular disease, presence of diabetes, presence of hypertension, etc. Dependent variables can be either binary or multinomial. Examples of categorical independent variables are gender, ethnic origin, educational status, smoking status, etc. To perform a chi-square test, you first calculate the expected frequencies of outcome for each of the categories of independent variable based on a null hypothesis. Then, you compare the observed frequencies or actual frequency obtained in the research with the expected frequencies using the chi-square statistic. If the calculated chi-square value is larger than a critical value obtained from a chi-square distribution table for a specified degree of freedom and a certain level of significance, you reject the null hypothesis and conclude that there is a significant difference between the observed frequencies and expected frequencies. The chi-square test is commonly used in fields such as social sciences, biology, medicine and public health to evaluate the association between categorical dependent and independent variables and for testing the hypotheses statements.